Hi, this is Bingrui. We all know that in the future, cities will encounter lots of problems, such as resource shortages. From the previous data analysis, it can be seen that the future of Australia will also meet some serious energy and environmental issues such as the lack of traditional energy resources and the environmental pollution caused by the massive consumption of traditional energy. Kiama is an ordinary seaside city in Australia, where there is a beautiful environment and a rich cultural heritage. However, due to the geological limitation of this place, the traditional energy production here is particularly low and mainly relies on imports. So the city is in danger of a total blackout at any time, especially when it comes to storms. So for Kiama, there is an urgent need to find new energy opportunities. Kiama is currently most dependent on traditional energies, mainly coal and natural gas, which together account for 60% of total energy consumption. Since traditional energy sources are not only limited in quantity but also particularly polluting to the environment, my main design strategy is to transform the way Kiama consumes energy by replacing traditional energy sources with renewable and clean energy sources to power the city. After the research before, I found that Kiama has the potential to develop some new energy sources, so this is my prediction of energy flow of Kiama City in 2100. Well, you can see in the 22nd century, the main energy sources consumed are wind energy, solar wind energy, and wave energy. Based on my strategies and research, I selected the most suitable site in Kiama for a new energy conversion station, where the city will collect wind, solar wind, and wave energy and use these energy sources to provide electricity and clean water for the whole city, as well as providing nutrients for the urban wetlands, thus maintaining the biodiversity and ecological of the wetlands. This is a diagram of the energy cycle in Kiama. Firstly, regarding wind energy, it is almost impossible to build a large wind power plant in the city of Kiama, because the current annual average urban wind speed in Kiama cannot meet the minimum requirements for wind turbine station, and the future density of urban buildings will be relatively high. Therefore, in this design, wind turbines are mainly built in the ocean, as well as special topography designed according to the mean wind direction of the city to increase the wind speed by the city seaside and obtain more wind energy. At the same time, these special topographies can also protect the city's coastline. Another major energy source is the solar wind. Although the conversion of solar wind energy into electricity is not yet fully realized, solar wind energy has a huge potential and contains thousands of times more energy than solar energy. The following are ideas from scientists on how solar wind energy can be converted.
Solar wind, using them to create an electric potential. That potential is then used to generate a current along a very long 1 centimeter thick copper wire that's pointing toward the sun. A flowing electric current generates a magnetic field. So now there's a cylindrical magnetic field around this copper wire, and that deflects more solar wind electrons toward a spherical metallic receiver. A tiny bit of this collected energy is cycled back to feed the current in the magnetic field, but most of it can be collected as energy. That energy.
So, in the 22nd century, we might imagine that this is possible. And because Gamma has experienced a geomagnetic reversal phenomena for tens of thousands of years, the magnetic field here is weaker than elsewhere on Earth and is more likely to pick up the solar wind. This means that if the same solar wind energy is used, Kiama will spend less than other cities to build solar wind energy conversion stations. The last aspect is about wave energy. By designing spatial coastal topography, the wave converge in one place and generate a huge power potential energy, which turns to the turbine and drives the generator. The electricity obtained can be used in nearby sewage plants to treat the wastewater and to transfer the biomass extracted from the sewage to a nearby artificial wetland to provide nutrients to the wetland. That's all. Thank you.